Myself, Ambojirao GV from AML Department C section. Our teammates are Chetan MJ and Jeevan Prakash from C section AML Department. We are here with a new assignment project to deal with the two operating system code and their errors. Let's go with an code for Windows. Chetan and Jeevan will explain in details. Yes, Chetan, go ahead.
Myself, Chetan, I am explaining about Windows code. In that, the provide code demonstrate a Windows-based fork designing to continuously create child processes, overflowing on system resources and potentially caching the system. The potential the program includes necessary headers like Windows.h and Studio.h on lines 1 and 2, which allow it to use Windows API such as create process for process creation and print for error reporting. On line number 4 to 8, an infinite work function is defined but it is never used. The function contains an infinite loop that would simultaneously a child process running indefinitely. However, the child process are actually created by the create process function in the main function. The main function starts on 11 with an infinite loop that continuously calls create process to create a new process. The start of info and process information structures are initialized on line number 13 to 17 using zero memory, preparing them for the create process call on line number 18. If the process creation fails due to resource exhaustion, the program prints an error message using print on line number 20 to 21 and exits with a failure code. On line number process and thread handles are closed on line number 24 and 25, but the program continuously create processes indefinitely due to the infinite loop on the line number 12. Next, Jivan will continue this code.
Thank you, Chetan. The primary issues with this code in the unbounded process certain in the infinite loop on line 12. Each leads to system resource exhaustion as operating system runs out the memory CPU time and process table slots. The child process created would neither run the infinity work function or neither program. In conclusion, more resource with each process swapped. The error handling for create process failures found lines 17 to 19 becomes the ineffective as the system already under heavy load when the process creations falls. While it good practice to close the process, the thread hands this code not prevent the exclusive creation of process. In conclusion, this code is an example of bond that leads the denial service conditional by creating the unlimited numbers of process. To prevent this code would be limited process creations manage resource more effectively and ensure the child process performs finite task before the termination.
Thank you, Chetan Jeevan, for explaining the Windows code. Let us move to on Linux code. Here we have a code to create a processes continuously. In this code, by starting including necessary header files from line number 1 to 4, which provides function for process creation, port, error reporting, and process terminating. A function called infinite work is defined on line 6 containing an in loop, while one that keeps child process running identically without terminating contains another infinity loop on line number 13 if paid lesser than 0, which represently called the fork system. This creates a new process each time it runs. If fork is due to resource execution, an error message fork failed is printed on line number 16 and the program executes with an error code. In the case of successful process creation, child process determined by if paid is equal to 0 on line number 16, called the infinitive work function on line number 17, and enter an infinity loop. Process on the other hand skips this block and return to the outer infinity loop to create more process. All through the program includes an exit 0. It is never reached because of the infinity loop in infinity work. Similarly, the return 0 statement on 21 will be unreachable due to the infinite loop in the main function. The error in this code infinity work. The outer infinity loop allows unlimited process creation, leading to exponential growth of process and rapid resource dissipation. Here in the child process enter at an infinity loop without terminating, concluding and CPU and memory. While error handling or for fork, failure is present on line number 14. It is ineffective as